In many practical applications, we need complete weather data sets for which no gaps are allowed. In this tutorial, we will describe a simple approach for filling gaps in weather series. Here, I have an Excel file with weather data for the year 2010. The variables that we have in this Excel are the date, the year, the day of the year, maximum and minimum temperatures, maximum and minimum relative humidities, wind speed, solar radiation, rainfall, saturated vapor pressure at the time of the maximum temperature, saturated vapor pressure at the time of minimum temperature, and actual vapor pressures at the times of the maximum and minimum temperatures. These records of vapor pressure at saturation or the actual vapor pressures have been calculated from the theoretical formulas that you can find in Chapter 5 of the Book of Principles of Agronomy for Sustainable Agriculture from the records of maximum and minimum temperatures and of maximum and minimum relative humidities. Okay, for filling gaps in the weather series, the first step that we need to take is to locate the gaps in our weather series. To this end, I'm going to create a new column that will contain the theoretical day of the year. This will be a column homologous to the one indicating the day of the year, but it will serve us as a control, and this will be completed with a recurrent formula until the end. Whenever we find a difference in the day of the year between these two columns, that will mean that the series is incomplete in that point. So if we scroll down, meanwhile we have the same dates, the same numbers in both columns, the series is perfect, but eventually in this exercise we will find that here we have a difference, and this is because the series is missing the day 250. So I'm going to give space for this date which is missing, and I'm going to update the formula. The next difference is found here after the day of year 253. Here we see that the weather series has not worked for 3 days in a row. So we must create 3 columns for as many days missing. So this will be the day 254, 255, and 256. Again, we update the formula for the control column. And in this exercise, we can check by going to the end that we have no other gaps in the series. Both columns go from day of the year 1 to day of the year 365. In this tutorial, what we propose is to use a simple interpolation approach for the maximum and minimum temperatures, for solar radiation, wind speed, and for the values of the vapor pressure, of actual vapor pressure, in the case of having a single day missing. For the case of rainfall, and regardless of whether it is a single day what is missing or several days in a row what are missing, we will have to use a regression analysis approach using records from a station nearby. The regression method will be used also for all the weather variables in case of having several days in a row missing. In the particular case of the relative humidities, what we have to do first is to get, either by simple interpolation or by the regression method, the values that correspond to the actual vapor pressure. And then, from the values of vapor pressure, we will deduce and from the values of maximum and minimum temperature, we will deduce the saturated vapor pressure and the relative humidities. Coming back to the Excel, we are going to start by filling the gaps for the day 250. So here, for maximum and minimum temperature and other variables, we can use a simple interpolation approach, which will consist of averaging the values of the days preceding and following the day what is missing. This procedure can be applied to maximum and minimum temperatures, wind speed, solar radiation, and the actual vapor pressures. The vapor pressures at saturation can be deduced from the values of temperature using the theoretical formulas, and the values of relative humidities at the time of maximum temperature and at the time of the minimum temperature we will deduce by from the ratio of the actual and saturated vapor pressures. So the maximum relative humidity in a day will be obtained from the ratio of the actual vapor pressure at the time of minimum temperature divided by the saturated vapor pressure at the time of minimum temperature. And as we want to express this relative humidity in percentage, we have to multiply by 100. The same goes for the minimum relative humidity. In this case, we have to use the estimates of vapor pressure for the time of the maximum temperature. For rainfall, as we said previously, we need data from another station. And I had already prepared data from a station nearby, the one we are working with. It appears in this second Excel sheet. I'm going to copy this data to the Excel sheet with our main weather station, weather data. Okay. We can check that the data for the supporting station is complete. It has also the 365 days. Yes. So now we are going to perform the regression analysis for the data of rainfall in order to complete the values missing of this variable. To do that, we are going to create a dispersion chart. Well, in this dispersion chart, we have we want to have the here the values for station, for our target station, and in the horizontal axis we want to have the data for the supporting station. In this case is the opposite, so we need to change the order of the axis. Okay. And now we can add a trend line and make Excel to show us the equation and the coefficient of determination of this regression line. This formula is what we will use to deduce the missing data of rainfall. So we have to take note of this coefficient of 0.8387. So for the day that is missing, we will calculate rainfall in our target station as 0.8387 multiplied by the rainfall recorded in the supporting station. The same formula can be applied to deduce the missing data in the next gap, including several days in a row missing. Well, in this case, the supporting station didn't record any rainfall event in any of the days that were missing. The same regression procedure is what we should apply for getting the data, for completing the gaps for maximum and minimum temperature and the rest of the variables. So for instance, we are going to do the same for maximum temperature. Oops. Okay. In this case, both stations have a pretty similar temperature. So we can use that coefficient and multiply it by the record of maximum temperature that was observed in the supporting station. So now we have the series complete for the maximum temperature and rainfall. For the rest of the variables, we have to follow exactly the same procedure.